Welcome to Surroundscapes, where Bluesound Professional dives into technologies and trends making headlines and causing thought in the world of commercial AV installation, including case studies and unusual applications of AV technology, as well as technical reviews and troubleshooting with emerging technologies like Power over Ethernet and decentralized networks. My name is Graeme Harrison, and I'm the General Manager of Bluesound Professional. Today's episode is our fifth and is a hot topics episode, and I'm focusing on the topic of decentralization. I'll start with a history of audio systems and their evolution, and we'll move on from there. I'm also going to talk at the end to Nick Larkins, co-founder of the business music service Qsic, about his practical experience in using decentralized intelligent systems to facilitate large deployments of audio systems in lots of different locations. So let's start with a bit of history. In the beginning, when I came into the industry, it was an analog industry. And yes, we were still using reel-to-reel tape decks. I had one back in the day, and they're making something of a comeback at the moment. Analog had a lot of advantages, and we knew it well, but it had a lot of disadvantages too. One of those is the cables in the system. So analog used a wide variety of cables with a wide variety of connectors, and they all needed to be terminated. They needed adapters. You can actually see some adapters in the picture here. And we had to deal with all of this. And we ended up with cable ducts that look like this. So this is actually a telephony one, but it could have been an analog audio one. And I've seen plenty of installations with cable ducts looking something like this. So I asked ChatGPT to draw me the topology of an analog audio system. And this is what it came up with along with its usual spelling mistakes and things. But that's ChatGPT's impression of an analog audio system. So it actually looks kind of like this. You have inputs, typically microphones, but other inputs in our world, music services, music files, coming into a mixing console or some sort of networked central device, and then going into some signal processors often, and then into amplifiers, and then finally into loudspeakers so that we hear it. So basically, all of the inputs come into one central place. Then through a couple of steps, they go out again to lots of output devices. So that's the topology of an analog audio system. It typically involves one central point. In the 80s, going into the 90s, the industry moved on into the digital domain. And that gave us a ton of possibilities. Audio transmission moved from the analog domain into the digital domain, into zeros and ones, and we could do things any way. But we actually ended up doing things in a very similar way to the way we did it in the analog domain. This is very common with disruptive technologies. Typically, the first generation after disruptive technologies emerge, use those technologies in the same way as they used the old technology. And so we started using digital audio in the same way as we did analog audio. So with audio, the endpoints, both the beginning and the end, are always analog. Our mouth and our ears are analog, and we need analog inputs and analog outputs. So often in the digital domain, those analog inputs came into some sort of input boxes. Those were then networked into a central DSP. They were processed. They were sent back out to output boxes, back into the analog domain, into loudspeakers. The same thing was happening in the video world, where technologies like HD-base-T came along and basically digitized coax video transport into Cat5, digital video transport. But you still had a centralized video matrix. So we were using the same sort of centralized architecture in the digital domain as we used in the analog domain. One of the big drawbacks of doing it this way is the congestion at the central point. So imagine you're in a city and you're a town planner. You could literally bring all of the roads in the city into one intersection. It's a way of doing things. It's not probably the best way of doing things, because if there's an accident in that intersection, that blocks up the whole city. And if you think about driving in a city, what you're doing nowadays is you've probably got Waze or Google Maps or some sort of GPS system, and it's telling you about what's going on in the city. And if there's a traffic holdup somewhere, you simply change your route and you go a different way to get around it. That's what we do when we're driving in cities, and that's what's possible in the digital domain. So in the digital domain, it is possible to make the middle bit the network. So at this point, you're using IT technology, switches, fiber converters, and you're building a decentralized network. And this network is reliant on intelligent endpoints. So you're doing a lot of the processing, a lot of the intelligence is devolved to the endpoints. And the center of the matrix is the network. Now, IT over the years has developed all sorts of technologies for redundancy. Spanning tree networks, rep networks, all sorts of technologies, so that if one of these paths is blocked for any reason, the signals automatically find a different way around it. That's what happens in the data networks, in your offices, in your hotels and bars and courtrooms and hospitals and houses. We're not dependent typically on one central point. We have ways of getting around things. Devolving the intelligence to the endpoint also allows for a ton of flexibility. You're able to switch out endpoints and change the functionality of systems. You're able to add more endpoints to expand your system, take endpoints away to contract your system. And you have total flexibility. In the same way, in a data network, you can plug computers in, either wired or wireless, take computers out when you go home. The network still exists. It grows and shrinks to meet the particular need. So this is what a modern digital network looks like. In the audio domain, we developed protocols to do what's called deterministic transfer of audio. Because real-time audio needs to have a guaranteed transmission time, technologies had to evolve so that you had the guarantee of a particular transmission time between point A and point B, no matter how many middle bits it went through, switches, fiber converters, whatever. No matter what routing it took, it had a guaranteed transmission time. As I say, that's called a deterministic protocol. It compensates for network latencies and allows for guaranteed transmission time. If you think of a lot of the data commands that we use in data networks, if I, for example, send a print command from my computer to a network printer, if the network's busy, that command might get buffered and my print may take half a second to come out. I don't really care because I'm just waiting by the printer, waiting for my bit of paper to come out. In any form of real-time streaming, whether it be audio or video or information like financial transactions, for example, or industrial process control, it's critical to have a guaranteed time to go from one end to the other end of the network. In the audio domain, there were many different initial protocols that came along, Ethersound being one of the early ones, Media Link being another one. And in the commercial AV industry, we coalesced around a protocol called CobraNet. And for many years, many manufacturers used CobraNet as their deterministic protocol to run audio across a network. Because we developed from there, we needed lower latency, higher bandwidth. We needed to move on. And the industry's moved on in a number of ways. Probably Dante, a very good protocol from an Australian company called Audinate, is the current industry standard in the commercial AV industry. There is an open architecture called AVB, based on a range of IEEE standards, 802.1 standards, and 1722 device discovery and enumeration standards. And that is also used in the industry. It's particularly used in high-end live sound, where most touring bands use a protocol subset called Milan, which is a part of AVB. And AVBs also ended up being used in a lot of different industry segments. Most cars use AVB now for their information networks within the car. A lot of wireless consumer audio and video transmission is done using AVB. So there are a number of these protocols that come along to facilitate this transport. We at Lenbrook have our own protocol, which is a 96K uncompressed protocol that we use when we group products. What really accelerated that trend and what we've been at the forefront of is using power over Ethernet. Once you use power over Ethernet, you're able to run one cable to the endpoints, and that's running both information and power. And what that leads to is the ability to really quickly put together sound systems. It's literally a case of walking into a facility, putting up one or more PoE switches, Cat5 cabling to the endpoints, and a load of loudspeakers. So the use of PoE and our use of PoE with intelligent network streaming speakers has really allowed for mass deployment really quickly. And when we talk to end users, whether they be in the corporate environment wanting to deploy meeting rooms across the world, or in, for example, a hospitality and retail environment where they want to put, in some cases, thousands, tens of thousands of locations online as quickly as possible, the speed of deployment is everything. Something else that's come up in recent years is the concept of remote monitoring, being able to look at your network and your endpoints, see what they're doing. This gives a lot of advantages to system integrators and also to larger end customers. They're able to see, an integrator, for example, can see into all of the installations they've done and in real time check that they're all working okay. They can get alerts if anything goes down. A big end customer can look at all of their sites and check that they're all online, they're all working properly. And again, get alerts if they're not. They don't have to be staring at a computer screen. They can get text messages and get Teams messages. They can get emails. So they can get to know whether a system is failed in a particular part or is likely to fail. In the example for an example here, sorry, I'll stop there and do that again. An example here would be an amplifier that's running hotter than usual. Is that because the fan filter is clogged and maybe you need to go and unclog it? Another example would be a projector where the bulb is getting to the end of its life. You can choose whether to wait until it blows or to go in preemptively and change that bulb. So monitoring gives you the ability to look at the system, to do often first-tier support work, repowering a system, firmware updating a system remotely. It really transforms the idea of after-sales service. It allows integrators to offer service contracts. It allows them to look at all of their installations from the comfort of their office, to do first tier, as I mentioned, support work without having to leave their office or old trucks, but simply do things like repower systems to see whether that cures the problem, put them into known states to see whether that cures the problem, do firmware updates to see whether that cures the problem. So there's a lot possible with endpoints that are intelligent. You can remote monitor a centralized system, and the common way of doing it in the past has been in the streaming music domain that we're part of to monitor the replay devices, to monitor the players in an environment. And you can go in and look, is your player working? Is your player not working? That's great, but it doesn't tell you whether you're hearing sound out of your loudspeakers, because your player could be working perfectly, but the amp could be blown or simply turned off. The speakers could be blown. You don't have any visibility into whether the signal is actually being heard in the space. Once you devolve the intelligence out to the endpoints, you can monitor at the endpoint. And Bluesound Professional have a number of PoE network streaming speakers, and we have alliances with a couple of monitoring services, Qsic and Demots, and you can even build drivers to monitor our devices yourself if you want. And you can actually see what the speakers are doing. And if you know a speaker's up and you know a speaker streaming, you know people are hearing. That becomes very important once you bring advertising into the mix, because advertisers want to know whether the signal and the ad that they've paid for is actually being heard by the customers who they're intending it to be heard by. It's meaningless doing data analytics on advertising if you don't even know your advertising is being heard. Now, this concept of intelligent networks brings a whole new area into play, which is the area of the cloud. You can now decentralize further, not just within the network, but outside the network, to the cloud. And we work with music curators that use machine learning and artificial intelligence to curate playlists on the fly and evolve them out to their sites. We do scheduling, we put messaging in, we build advertising in, all in the cloud. So a lot is possible in the cloud, even adaptive algorithms like ambient noise compensation. We can take sensor inputs into the cloud and look at, for example, how many people are in a particular location and what does that drive in terms of behaviors. Does it drive louder volume? Does it drive, for example, playlists with higher average BPM? Does it drive different advertising? So all of this can be devolved outside the network to the cloud, and being able to monitor right to the endpoint allows this to happen with guaranteed transmission and guaranteed monitoring. And then you can deploy these systems really quickly. So I now want to introduce to you Nick Larkins, who, as I mentioned earlier, is the co-founder of a business music service called Qsic that originated in Australia but is now worldwide. And they're doing a lot of these things in real-world applications right now. So I'm here with Nick Larkins, who's the co-founder and CPO of a really innovative business music service called Qsic. Qsic's a great partner of ours, and we've done some really interesting work together. And I thought I'd bring Nick in to add some color to it all in real-world situations. So, hi there, Nick.
Hey, Graeme. Great to be here again. Looking forward to it. And excited to be on this episode.
So can you start off by just giving us an idea of what Qsic actually is?
Yeah, so Qsic's been around for 10 years and we've evolved quite a lot. But I think, we do supply audio solutions to retail businesses, large scale retail businesses. And we really center ourselves around the retail media ecosystem. So what we do is really turn audio into a revenue stream for retailers in the C-store, grocery and QSR sector. Anyone with huge amounts of scale, with huge audiences that are able to leverage their audiences that they have in these stores and the products and services that they sell within them to turn audio into a commercial advertising platform for them.
Yeah, I mean, that's kind of the rough outline, but really what you're doing is very different and very innovative, and this partnership has really changed the course of our business. We were looking mainly at small to medium-sized installations, and we do lots of those. But with you guys, we've been able to get into doing some really large deployments. I know that you've always favored kind of smart endpoint solutions throughout the development of your company. Can you tell us why that is?
Yeah, I think, look, my background's in the AV industry. So I've been in it for since I left uni. So coming up on 20 years. And I kind of really saw my journey started in that transition period of, analog audio systems kind of evolving to the digital kind of world. And then, with the, Matt and I starting a business in Qsic and having this kind of AV background, something that we always valued was control as close to the speaker as possible. We working with, some of our early customers like the McDonald's of the world back in Australia, listening to the pain points that, businesses like that had with traditional audio providers was that they really relied on their staff to manage those systems and, for them to create a really successful customer experience. You needed great managers to make sure that, the audio system was on, the volume level was up. And, to do that at scale is really hard, right? Like scaling to 600, 700 stores, you really, you're going to be clutching at straws to find, a team of 700 managers that could constantly kind of manage that in-store experience. And for us, we saw that problem as easily solved given the rise of, smart speakers and smart amplifiers, where we could really get visibility and take over the control of the in-store experience at that endpoint and unlock, again, I'll touch on it, that visibility and control for these businesses that have huge scale networks, and allow them to control it like they've never had before. And you can start to do some really interesting things around automating that experience because you're in direct control of that infrastructure. So from that, we obviously, our mission at Qsic's been centered around analytically showing the value audio can bring for these businesses. And to achieve that, if you don't have that visibility and control of the experience in store, then it's really, really hard, because if you're a traditional media player sitting on an analog amplifier, you lose that visibility at the media player, because there's so many different points of error that we can't see. So for us to tangibly go out and showcase that this is the impact that we're having, is really hard, because we can't guarantee what's happened in store. And the rise of platforms like Bluesound has given us that ability and confidence that when we're executing in store, things are actually happening. And that's why we're really big fans of these decentralized platforms, because it helps us achieve the mission that we're on in a really confident and compliant way, I guess.
Mm-hmm. Yeah, that's it's interesting that, as you said, your growth kind of happened at the time when the industry went from analog to digital, and initially we used digital in the same way as we used analog. So we still had centralized systems. We were just running a signal digitally rather than analog. And really this most recent shift to decentralized systems using the network as the matrix, and as you say, being able to monitor to the endpoints is hugely important. But another area that has kind of shocked me as we've worked together is this, both the size but the speed of these deployments that you're doing. And when I look at it and I tell people, these things are happening at tens of sites a day, people are shocked. But this idea of just being able to hang some intelligent endpoints, a Ethernet switch, watch some lights come on and move on, is really critical to achieving deployments at the scale that you're doing. And it's been interesting in my work with AVIXA, with the leadership search committee, talking to corporate AV people that work for the customers, the large multinationals. That's what they're all about. We would love to think it's all about the quality of the solutions they provide, or that our gear is wonderful. But for them, it's, we need to get stuff out quickly and reproducibly, and we need to be sure it's working. So speak a little bit about that kind of speed of deployment, because that must have been something you've had to learn as you've scaled.
Yeah, absolutely. I think, what is interesting, having our solutions, having a network backbone, for one, outside of the speed of deployment, is all these stores are becoming more connected, right? Everything's reliant on this network, and the benefits of that, I've already touched on the visibility, but for IT teams that work in these large retail networks, they love the ability that they can see and manage these devices as well, and they can take control and just alleviate any pressure that was traditionally required from in-store staff to manage these systems. If they can remotely manage and monitor and proactively kind of fix things because they can see things happening on their network and they're being alerted to, there's so much benefit to that. There is a little bit of upfront work, I think, when we do engage with retailers on, going through that whole IT kind of process, security, firewall policies. But once that work's done, then, being able to execute at scale and at speed, it just makes things so much easier, right? For example, we're big fans of the BSP 200, which are the PoE Bluesound speakers, and we're able to kind of use, our customers' kind of data technicians, because they all know how to run data cable, right? They're already running data cable for the screens, the point of sale systems, the printers at the back. And so being able to kind of have a standardized cabling kind of, policy within these stores is huge. And then, being able to run one cable to a speaker, plug that in and have that powered over the Ethernet cable alongside having the network connection to it. And then, being able to commission it at the switch, because we've gone through all that upfront work with the IT teams. It makes it so easy to activate. The lights come on, they can see that it's online. There might be a configuration that we've pre-provisioned into the system. So that post-commissioning process that an installer might need to do with a traditional system isn't there. So we can be in and out within hours for a 4 to 6 speaker deployment. So yeah, I think it. And then going back to what I touched on, those benefits of support from an IT perspective is just huge.
Mm-hmm. Yeah. Yeah, a lot of the work you do, it's interesting because you're both a music service and a control system for us. You're
Mm-hmm.
both providing us content and telling us what to do, which is kind of really interesting. Something you touched on, which I think is really important, is our role of being good network citizens and our role of understanding networking. And this is something the industry's really got to get its arms around, that increasingly we are network endpoints, we're network devices, we're part of the Internet of Things. And I think in our industry, people see networking as kind of a little thing on the side, a little thing that enables a product to be controlled by a computer, for example.
Mm-hmm.
Whereas it's the core of what we do. And as you say, once the cabling becomes unified, once it all becomes Cat5, and once the network becomes the matrix, then cabling AV systems is no different to any other data system. And it's kind of an interesting change in the industry. And I know from working with you that you've had to find provisioning partners that can provision at scale and get in and out quickly without wanting to kind of tweak every system like we would back in the analog days where you'd spend a ton of time tweaking a system. Have you found that to be a difficult thing to find partners that can do that?
I think I think that's something that we've been constantly working on is, alleviating the amount of work that we need third-party partner to do to provision our systems. So we put a lot of that. We've constantly working on auto provisioning as much as possible. So if someone is provisioning something, one of our partners are provisioning something in their warehouses, it literally just we just plug it in, and it kind of, it knows the store ID of the client that we're working with, and then it can pre-provision that platform. And now we're kind of working on it to the point that you don't actually need to unbox anything in a warehouse. We can ship it to a store, and it's literally plug and play with a really user-friendly kind of provisioning software that can happen on site for them to auto provision it. I think it's interesting as retailers too, start to get a lot smarter around how their networks are built. Edge computing is becoming such an interesting kind of field for large retailers, because cloud computing is great, but networks can go down, internet can go down, so you need to kind of have the applications smart enough to run locally. So if you can virtualize your application to sit on these kind of edge servers that a lot of these retailers are starting to deploy, and we can work with the IT teams internally at the retailers to say, hey, this is the deployment that we're looking to facilitate throughout your network. This is the application that we need to host on your, on your servers at those locations. And then, kind of marrying that up to the hardware that we're starting to deploy on the network, on that, on that VLAN or however that looks, and being able to kind of automate that whole process and do a lot of the upfront work with IT so that we don't need, the installers or our partners to get too technical on the provisioning side of what we're deploying. And, all that's possible with this kind of technology, right? Like, working with partners like yourselves to help, to help us in reducing the friction of getting this, this kind of infrastructure in store is what we really value from a partnership. But yeah, we're just trying to make it as easy as possible to get these solutions into stores. Our chairman actually loves to use the analogy is that, we need to sell the iPhone to these retailers to use the application. And we need to make that process as easy as possible. And provisioning and deployment is part of our product offering. We want to make sure that we're the best in the business of that. And for my job as a product officer, as much as I'm like focusing in on the software and, the AI and everything else is driving value for our business, this is part of the product offering as well that I'm constantly kind of, trying to work with my team on improving and making it a really great experience for retailers as we start to onboard and deploy this technology.
Excellent. Thanks, Nick. I think I want to circle back to something you said early on in conclusion, which is this idea of really intentional retail media strategies. And you're really at the forefront of that, kind of from two different areas. One is providing meaningful content. So being able to really reprofile brands and hone their branding and engage their customers. And as you also say, to drive revenue out of advertising from partners and to make the AV system a net positive to their cash flow and their P&L. Is there anything you want to say before we end?
Audio just is such a powerful channel for retailers, outside of just, the advertising component and communication to your customers, creating and just simply activating music in an environment can change the game. I don't need to tell you that, Graeme, you know that better than anyone. So, for us, retailers thinking more so around their physical environments and how they can use these to create unique experiences that you can't capture in the online or the digital world, right? That has captured so much of everyone's attention. We spend a lot of our time on our phones, on our computers, and for brands and retailers, the physical store is everything, and so it's such a powerful kind of channel for them to start engaging in a unique way that you can't capture digitally. So I think that's something I'd advise a lot of retailers to think about, because there's so many spaces that I walk into here in the US that don't have anything playing, and that there's not enough thought going into the actual consumer's experience and using these spaces to really connect with the customers that in a way that they can't do on an iPhone application. So I think that's where I'd love to leave it.
Okay, thanks very much, Nick. Thanks for your time. And I recommend viewers to check out what Qsic is doing. It's really innovative. It's the future of the retail media industry. So thanks a lot, Nick.
Thanks, Graeme. Always a pleasure. And had a lot of fun.